In machine learning and in real life, we sometimes want to group or classify data in an unsupervised way, that is unlabeled data, maybe based on some certain features they share without forcefully having to know those filters. K-means clustering algorithm is one of many methods that allow us to perform this task. Real life examples include classifying images or objects based on their resemblance, grouping documents based on their content. Clustering is used when we want the machine to propose its own solution to a problem. Say for example, you have a set of items in a bag which you do not know the items, but you want actually those items to be classified based on particular features they share among themselves. That is where the clay clustering algorithm comes into play. Take for example, the random box input here shows some unknown data we would like to classify to something like that of output. So as a human, if I pass you this image here and I ask you to classify it, you might classify it based on certain observable features you see using your human senses, which may be the sizes of the stars, the number of branches each star contains. So this classification here is based on your own human senses, and you might likely obtain something like this. But how do we do this using the k-means clustering algorithm then? How does the k-means clustering algorithm works? K-means is an iterative clustering algorithm in which we ask the computer to find a number k of clusters in our dataset. For this, the computer starts with a random guess for k in the data space, and these points become centroids in our dataset. So in our dataset now we have centroids 0, 1 and 2, which are random. The data space here shows 3 centroids randomly thrown into the dataset. And these centroids here represent the value of k and were randomly chosen by the machine. So what happens now? Each data in the dataset associates itself or forms a grouping with its closest centroid. And this is to distinguish between features, since similar features will be closer to each other in the dataset field as plotted. The centroids move to the average center of mass of its group. Then the new position becomes the new centroid for that group. And the process continues until the centroids no longer move, meaning we have fully classified the set. But now comes an issue. How do we accurately determine an optimal value for k? Because remember, k is just a random guess by the machine. Say we now have 1,000 features to classify. A random guess for k is not enough to ensure full classification. If k is too small, the variance is weak, meaning the dataset is underclassified. And if k is too big, the variance is strong, meaning the dataset is overclassified. In both cases, we have an issue because we wish to have an optimal value for k, so we have an optimal variance, ensuring optimal classification. Variance here represents the global separation or global distance of the point with respect to their centroids. And luckily for us, there exists a method to help us find the accurate value for k, and it's called the elbow method. The elbow method consists of testing each random value of k and measuring the variance for every clustering, then plotting this on the curve, and the optimal value is gotten at the elbow of the graph. We see on this graph here that if we continue to k equals 5, the graph curves up and we have an elbow at k equals 3, which is the optimal value for k. Now we understand how to get the optimal value for k, and we understand how the clustering works. Hence, we fully understand how the k-means clustering algorithm works. If you want to see an implementation of this in Rust, make sure you subscribe to get notified when I upload it. With that, see you in the next one.